Okay. So today we're actually on day 2 of our Stats 2 course, and we are going to review Chapter 7. So, Chapter 7 we covered in Stats 1, and Chapter 7 we talked about the normal curve. So, Chapter 7, this will focus in just a second. We just have to give it a minute. Chapter 7 in Stat 1, we talked about the normal curve, and this is where we started talking about probabilities and calculating probabilities. I shouldn't say start, because we start in Chapter 5 when we actually cover probability, but this is where we start calculating those probabilities. So before we get into calculating probabilities using Minitab, I actually need to go over something with you quickly, and maybe not so quickly at first, which is the normal probability plot. I don't know if you guys remember this from Stat 1. If you took Stat 1 with me, I rarely wrote it out because it's too long and we shorten it to NPP. I mean, everyone shortens it to NPP at some point. But normal probability plot means NPP. And what this plot is, so this is a graph. So this is a scatter plot of our data against what we would consider normal data. So normally distributed data, okay? So bell-shaped data. If the NPP is somewhat linear, then we went ahead and we would assume normality. So if you remember back in Stat 1, I try to focus this camera a little bit. That might not be any better. So what we did in Stat 1, we took a look at an NPP and we asked our technology, maybe it was Minitab, maybe it was a calculator, and we asked our technology to draw this NPP for it. It wasn't anything we did by hand. And what it did was it took our data set and it put it up against data set that would be normal for the numbers we had, okay? Would be bell-shaped for the numbers we had. And it took that and it put it against it and it draws a scatter plot. And when we look at that, and we just did a quick visual test by just looking, and if it was fairly linear, then we went ahead and said, okay, that our data was normally distributed, meaning it was bell-shaped. And that was great for Stat 1. But now in Stat 2, we're going to take it a step further, and we're going to introduce what we call the normality test. You guys, we use this test throughout the entire course, so it's very important that we understand the normality test and what it does for us. The normality test is going to do the same thing that the NPP did for us in Stat 1, and we're still going to use the NPP. And again, like I said, we're just going to take it a step further. So, so for the normality test, we're going to get the graph from Minitab. So we won't do anything by hand. We're going to use Minitab for this. And Minitab will give us what is called the Anderson-Darling p-value in our NPP. It's part of the output with the NPP. We get this p-value. So we're going to use this p-value to see if we can assume normal. So instead of just looking at the NPP and seeing if it's linear, we're actually going to complete a normality test. You're going to see some similarities to a hypothesis test without the full write-up. And we're going to take this p-value and see if it's normal. So I'm going to see if it's bell-shaped, normally distributed. That's what I'm talking about. So let's take a look at what this might look like for a write-up. Again, guys, I scan these in. These will be available. I can always bring them back up here, but I just want to keep writing. I'll try to leave it here a little bit like that, if that's helpful for anyone. Okay, so remember when we did hypothesis tests back in step 1, we always had our null hypothesis and we had our alternative hypothesis, right? Our null hypothesis for our normality test is going to be that we can assume normal, or we can assume normality, okay, however you want to write it. And our alternative is just the opposite, that we cannot assume our data set to be normal, okay? So there's our two hypotheses for this normality test. And what I want to remind you of is that, and I'm going to write it here, how we went about this when we were in step 1, that if our p-value is less than our alpha, then we reject our null hypothesis. But if the p-value is greater than our alpha, then we do not reject that null hypothesis. So if we think about it, if we are trying to assume normal, then we want the second part here to be true, right? We're trying to assume normal, so we do not want to reject that we're assuming normal. Does that make sense? So we want our p-value to be larger than alpha. Okay, so we are hoping for the p-value to be greater than our alpha, which I want you to realize that our alpha here is almost always .05. So I don't think we ever use anything different than 0.05 when we're doing a normality test for alpha, even if we're doing something different. But I guess once in a while it might be noted to use a different alpha here, but I don't even know if I've come across that in the course when I teach it, like if I ever have an example or anything where it's different. Okay, so my alpha is just about always 0.05 here. So what we want is we want to assume normality. So we want our alpha to be larger than 0.05. So we do not reject the null, right? Because we want that. And Minitab's going to give us the output, and we just have to look for that p-value and compare it to the alpha and do maybe like a little short write-up, okay? It won't be anything really long. So I'm actually going to share my screen with you different from my camera here. I'm going to pull up the notes, and I just want to show you what it looks like and just show you an example before we actually do it in Minitab. So I'm going to share my screen and we'll see if I have the notes. I do right here. So let me find it. So I have an example on page 5. If you wanted to look at the notes, or you could just look at what I'm pulling up here. Sorry, it was down because I had the example pulled up. Okay. right here. Okay. So here is an NPP. I'm just going to zoom it in a little bit. So here's an NPP. It's our normal probability plot. This is what the output would look like for a Minitab. And we can see visually all these little red dots are between the confidence bands. I'm saying that those red dots look fairly linear, but that's what we did in stat one. We want to take it that step further here in stat two. I'm going to go ahead over here and I'm going to look at the bottom number. It says p value. I don't care. It's not that I don't care, but I'm not going to study the mean, the standard deviation, the sample size, and this AD. So some people want to say AD because I told you it's Anderson-Darling, but it's still Anderson-Darling p value. So it's still that p value, which is that last one. I'm just telling you the actual name of it before. So don't get confused. It's not the second to last, it's the last one. So what we're looking at is the p-value of 0.931. Okay. So when I see that on output, of course, yes, that's greater than 0.05. So it's still almost like a little visual thing because you're just looking and you're just thinking about it in your head. And then you're going to do a quick little write-up. So I'm going to show you how to do that write-up for this one. Okay. So I'm going to just switch back and we can do this little write-up. So I'm going to just say, let's take a look at the example, which was example number 1 on page 5. So anytime I write this, just know these are always the examples listed in the typed notes, and I try to always include the page number so there's no confusion, okay? So example 1 on page 5 of the day 2 typed notes, we took a look at the output and we were given a p-value that was equal to 0.931. So, and we can see that it was linear. So we're going to ask ourselves the question, is this greater than, or you could say, is it less than, since that's what we normally do. And it is greater than, so we can accept that normality. So what I would do here for a little write-up, and this is what I'd like to see from you, I'd like you to write, okay, the null is that we can assume normal. And my HA is that we cannot assume normal. It doesn't have to be anything fancy, just something really quick. You're going to report the p-value to me, which is 0.931. You're going to say, you could either say p-value or you could say 0.931 is greater than 0.05. So you're going to say we cannot reject the null, and I want you to tell me what that means. So we can assume, normality for this data set. Okay, we didn't actually have the data set, but we just had the output from Minitab. So this is like the little mini write-up you will write for me when we're doing a normality test. Okay, I'm just gonna write it here. You guys, we do this throughout the entire semester. We do this all of the time, this little mini normality test. And this is what I like to see. I like to see what your null is, your alternative, your p-value, you comparing it to 0.05 and what it means. This last one means a lot to me. So you're stating, okay, we can assume normality, all right? It doesn't have to be anything fancy, just list it out real quick. Okay. Any questions on that? I don't have an example that I'm going to show you that just yet. We will get to that. But when I'm just going to share the screen real quick. I don't have any numbers. Oh, of course, I don't have my Minitab open. So I will look at that here. Try to figure out how to get my Minitab open when I'm on a full screen of the Zoom. Okay. All right, here we go. So I'm going to share the screen just so you can see Minitab real quick and just see where I would go. So when we're looking at this, we're going to all right. So when we're in Minitab, we're going to go back to graph because the NPP is a graph. I'm going to go to graph, and then I'm going to go all the way down to probability plot, and it's like a third of the way down right here, probability plot. Just so you know where it is. We don't have any data yet to try it out, but I just like to show you. You have single or multiple. We're going to try both as the semester progresses. I just like to show you where it is. Okay. All right. So we'll go back to the notes here, and we're going to move on to the next thing I wanted to show you and talk to you about. So now I'm going to go back to the normal curve, stuff that we were, that this whole chapter 7 is about. So when we're looking at the normal curve, I'm not going to just show you the normal curve, but I actually want to show you the normal. I keep using this bad black marker. Normal and standard normal. There we go. Okay, so normal and standard normal curve. This was what chapter 7 was all about. And I'm going to just do a couple drawings for you, and we're going to take a look at how to have Minitab help us out with this. So if you remember, the normal curve is just a bell-shaped curve. Oh, that's not too bad of a drawing, if I say so myself. And when we're looking at the normal curve, it's cut in half, right? So the area over here on the left is equal to 0.5, or I can say 50%. And the area over here on the right is the same. It is 0.5 or 50% right here. And the middle is the mean. So remember, the mean, most of the time we're going to view it as X bar. I'm going to refer to it as the population mean mu in our calculations right now, but just know it's the mean, right? So that is my normal curve. Now for my standard normal, because we're going to look at it all at the same time, since this is review, my standard normal curve, if my horizontal line, instead of the black one here, be here, it's still the center, right, where it cuts it half and half, but now my standard normal brings the center to 0, and you have all these positive numbers over here on the right and all these negative numbers over here on the left. This is my standard normal. So remember, the standard normal just standardizes everything so you can compare apples to apples. And when we're looking at this standard normal, we're going to use the z-scores. And that's what standardizes everything for us. So remember, our standard normal curve is our z, right? And when we're looking at z-scores, we had z is equal to our data value minus our mean. So right there, I'm using mu as mean, and I'm going to use population standard deviation, sigma, in our denominator. So I'm going to write a little key code here. So X is the data value that we're interested in, right? The location. And mu is the mean, and sigma represents my standard deviation. Okay. So if we got a z-score that was +1, all that says is that my data value is 1 standard deviation above the mean, the center of 0. If you got something on the negative side, it just means it's below. So if you got like a negative 2.5, it would be down here. And that would mean that your data value is 2.5 standard deviations below your center, your mean. Okay, so that's what we're looking at. So we're going to, excuse me, use Minitab and we're going to find these probabilities. We're going to find the area. So we have different things when we're looking at the normal curve and standard normal curve, and we can go two different ways. So the first way is that we can find the probability, which is the area under that curve. So if we are given a value, we can find the probability, squeeze it in here, of a value less than or greater than or in between. And I want to show you this, and I want to address these three. Okay. So what we're going to do, we'll take a look at an example right away and work through it. So let's take a look at example number 2, which is on page 14 of the typed notes. So what I will do is I will pull that up and we'll take a look at it here together, and we'll look at Minitab 2. All right, so let me get to page 14. Sorry if that's kind of making anyone dizzy because I'm going through this really fast. I apologize. I don't even know what page I'm on. Oh, 11, okay. There we go, page 14. All right, so here's some examples. We're gonna look at example 2. So maybe example 2, it says, suppose X is normally distributed, right? So I need to know that before I can calculate an area based on it being a normal curve, right? I need to know that it's normally distributed. So it's telling me. And then it says the mean is 75 and the standard deviation is 4. And it says use Minitab to calculate the probability that X is less than 77. So let me just show you, when I read through something like this, what I do. So when I look at this, I'm going to write down all the information that I'm given. So I'm given that the mean is 75. You can write it as X bar, it doesn't matter. And the standard deviation, I'm just going to abbreviate standard deviation, is equal to 4. And what we're looking at is we want to know the probability. So there's no context to this problem. We're just given numbers and we just want to simply calculate. So the probability that X is less than 77. Now, if you remember back in stat 1, less than was what you always got from your technology. So what you're looking at here, and I'm just going to quickly draw out. Remember in stat 1, it was like the thing I always said is do a quick drawing. It only takes a second. If 75 is there, then 77 is somewhere here to the right of it. It doesn't matter where. And less than means I'm calculating everything to the left. So since 77 is above the halfway mark, this whole area to the left is going to be greater than 50%, right? It's just nice to know. It's nice to kind of have an idea in your mind. So let's open up Minitab. So I'm going to share my Minitab screen with you here, and we'll work through this together. So, okay. Sometimes my toolbar doesn't show up, okay, like it just did now, and it's okay for my Minitab. All right, so anyways, we're here. I don't have to put anything in my data down here. Like I don't have to put any numbers in any of the columns or anything for this. I can if I want, and I'm going to show you both ways, but I don't have to. So if we want to calculate a probability, I'm going to simply go up to Calc in my toolbar. And I'm going to click on that, and I'm going to go all the way down, almost to the bottom where it says probability distributions. Then I'm going to go over because I have that arrow, and then I have this huge menu, and I'm going to go all the way back up to the top, the second one from the top where it says normal, because that's what we're looking at, a normal probability distribution. So I'm going to click on that normal. Okay, and then it brings up the screen. So remember, I always have to tell Minitab what to do, but I have to give it the input and the information. So I have a couple different things. So you could see this is the default, right? This is what will always come up. It will always come up at as cumulative probability, and that's exactly where you want it for what we're doing. And it has the mean here, standard deviation, it has some stuff down here. And then normally over here on this left, and it's just blank, if I had data in any of these columns, they would show up here, okay? Just so you know. I just don't have any data, so there's nothing to show up. So I'm going to leave it on the cumulative probability. That just means I'm going to calculate the probability. And here I'm going to type in my mean, which it was given to me as 75. And I'm going to type in the standard deviation, which was given to me as 4. Okay. Now here, I need to tell it what I want it to calculate the probability on, which was less than 77. The Minitab's always going to give me less than. I don't have to tell it less than. It's just automatically going to give me less than. So if I want in between or greater than, I have to do something different. But right now I don't. It's just less than. So input column would mean that I have data in this column and I want it to calculate the probability based on the mean and the standard deviation here given. I would want it to calculate these numbers, the probability on those numbers. So I'm actually going to check the box here, or the little dot that says input constant. So it's just saying, okay, I'm going to give it a number, which was the 77. I don't have to do anything for optional storage. It's just going to pop right up here on your screen. So I'm just going to click OK. And now I have my probability. So what it's telling me is that the probability, and I'm going to switch back over, that the probability that X is less than 77 is equal to 0.691462. Okay. If you've taken stats with me before, I usually prefer like 2 or maybe 4 decimal places. You can go as far as you want. I would say stick to 4 if you can. But what this is saying is that this whole area under the curve right here is 0.691462. Okay, so that's fairly easy because you don't have to change much. You just have to put some of that information in. Now, what if we wanted to do something a little different? We have to just make a few adjustments and it's still really simple. But before we do that, I actually want you to interpret your results. So stats isn't just about calculating. I hope you've noticed that by now. But after taking step 1, it's not just about calculating, but it's taking those numbers and putting it into words. So I'm actually going to share the screen instead of writing it out. I'm just going to share the screen and show you in the typed notes what I mean by that. So what I mean is, here's their screen. So I'm going to go down to the next page. So that's where the completed example will be. Sorry, it's like so slow when I arrow down. Okay. So, oh, wrong one. The number 2 right here. Okay. So if I ask you to do this, I would expect you to take that Minitab output and copy it and paste it into your Word doc. Then right here, so we could see if it's less than 77, right here is the 0.691462. And this is the write-up in yellow with a mean of 75 and a standard deviation of 4. The probability that a value is less than 77 is 0.691462. So you're just writing out your answer in a sentence form. Okay. Now this doesn't have any context to it, so there's no meaning behind the numbers. We don't know what they represent, so we don't have any context to our write-up. But if you did, and I will show an example with context, then we're going to add the context to the write-up as well, just so it has some meaning. Okay. So before we do that, I actually now want to calculate. I actually want to take this a different way, and I want to calculate the probability that X is greater than 77 real quick. So what I'm talking about, I'm going to use the same picture as I'm talking about over here in red. So I want to calculate the area under the curve here. Well, it's just the opposite of the 0.69, meaning Minitab doesn't know how to tell me area to the right. So this is what I'm saying, like it's still easy, Minitab, I just have to take it a step further. So anytime I'm going to calculate area to the right, I'm going to take 1 minus area to the left. So I just want to write that down somewhere here. So area to the right will equal 1 minus area to the left. So hopefully that's simple to understand. So for this example, so if I want to know to the right, so probability that X is greater than 77, greater than is always to the right, that will be 1 minus the probability that X is less than 77, the area to the left. Well, we already have that because we just found it in that example. So 1 minus 0.691462. So I get 0.308538 is the area. So this area right here. Okay. So I hope that makes sense, that we just subtract 1 from the area to the left. Now, if you're going to do something in between, it's still kind of the same idea of subtraction. Okay. So again, we would do a write-up. We would say with a mean of 75, a standard deviation of 7, the probability that a value is greater than 77 is 0.308538. Okay, you would just put it into words. Any questions on that one? All right. You know, guys, if you don't have questions, or maybe if you have questions but you don't want to ask in the middle of class, it's completely fine. Just let me know when lecture is done that you have questions, or send me an email, something, reach out some way. Okay. So let's take a look at an example where we're calculating in between. So here I want to take a look at example number 4, which is on page 14. Okay. So I'm going to pull up the typed notes so we can view this example. So I'm not writing it all down since it's already right in front of us. So I'm going to share these notes. So example 4 on page 14, right here. So example 4, it says a variety of white wheat grown locally has a yield per acre that is normally distributed. So that's key, right? We need to know that. With a mean of 50. So I'm going to start writing stuff down. So if I had the paper in front of me, I would circle it or underline it. Or since in this case it's online, I'm going to write it down on a separate piece of paper because I don't want to lose track of all that information. I'm going to write the mean is equal to 50. I know you guys can't see me doing it, but I am writing it. And my standard deviation is equal to 5. So, and it's bushels. So using Minitab, it says to calculate the probability that the yield of this variety of wheat for a 1 acre field will be between. So we're looking at in between. So I'm looking at between the 46 and 53 bushels. So I'm just going to share this so you can see what I wrote down. So I wrote down all the information from that example. I wrote down the mean was 50, the standard deviation. I can write sigma here because that's what it is 5. And this is my probability notation. You know, guys, we're not always the best at writing the probability notation, but we need to be able to write it so we know what's going on, right? So the probability that 46 is less than X, which is less than 53, because I want to know if it's in between 46 and 53. The key for writing the notation, when it's in between two numbers, you always write the smaller number on the left and the larger number on the right. So, you know, if you've taken stats class with me before, I draw everything out. I need to see this visually. I don't really need to, but I like to, right? Because I just think it's so helpful. So my center here is 50 and I'm looking at 46. I don't know how far it is. It's probably further than that, and that's okay. And 53. It just gives me an idea of what we're looking at, and we're studying and trying to find the area in between. So that shaded area, that's what we're trying to find. So we're going to use Minitab to do this for us. So I'm going to share my screen so we can take a look at some Minitab. And I'm going to show you actually now, instead of doing that input constant where you just had the one value, where I'm going to actually use the column. I don't even have to name the column. I can leave it as C1. But if we think back, we wanted to know between 46 and 53. So I'm going to put both of those numbers in, 46, and then I'll put 53 right below it. Okay, so those are the only two numbers I'm really interested in right now for this problem. So I put both of those in. So now I'm going to go back to where we went before, which was calc probability distributions. I'm going to go all the way up to the top, second from the top where it says normal. So I'm going to click on normal. I'm going to keep it the way it is because I don't want to do anything other than calculate probabilities. So I don't need to change this, is what I'm talking about, these first three options. I'm going to leave it in the middle at cumulative probability, the default. So my mean, it has 75 and 4 because remember we just used this function for the last calculation, the last example. So what happens is it stays there. It doesn't go back to the default unless I opened a new mini tab page. So we wrote down the mean, which was 50, and the standard deviation, which is 5. Now, instead of input constant, you could leave it there. I'm just going to take it out. I'm going to do input column. Now watch when I put my cursor here because there's nothing here right now, but watch when I put my cursor here. All of a sudden C1 pops up because I can choose C1. And I am going to choose column 1. The reason why I'm going to choose it, and I just double clicked on it and it brought it right to where my cursor was, is because I want to calculate the probability to the left of 46 and to the left of 53. So I'm just going to click OK. And now here's my output. It doesn't look like a lot, but it gives me what I need. So I want you just to kind of get in a habit of just checking on the top where it says normal, mean 50, standard deviation 5. Make sure you type those in correctly, right? Because if you accidentally typed in 51 or maybe 6 or a different number here for 5, then everything's gonna be thrown off. And it's just like kind of an easy check right there. So I'm just going to write this down. And you can look at the notation. It's the probability that X is less than my lower X. So here's a lower X, 46 and 53. So right here, I have the probability that X is less than 46 is equal to 0.211855. And I'm given the probability that X is less than 53 is equal to 0.725747. So I'm going to stop sharing that and go back to our drawing. So what I want you to realize, so I just wrote this down, okay? And that's what it was saying in Minitab, and I just wrote down the answers that was given. So what happens here is this less than 46 is everything here in blue, okay? I don't know if you could really see the color difference or not. Then the less than 53 would be everything in red, everything, even the blue. So it's like the black and the blue put together. So what happens is if I want the in-between, I need to take the probability that X is less than 53, which is the 0.725747, and I need to subtract the blue, which is the probability that X is less than 46, which that was 0.211855. So I'm going to take the red and subtract out the blue, and I'm left with just the middle. And that's exactly what I want. So when I subtract these out, I get 0.513892. So the area in the middle is 0.513892. So now we need to put this into words, and it's not just into words, but it's into context as well. So what I'm going to say is with a mean of 50 and a standard deviation of 5, the probability that the yield of this variety of wheat, sorry, I feel like I'm scribbling a little bit, for a 1 acre field will be between 46 and 53 is 0.513892. A little bit more than 50% chance that's going to happen. Okay.
Sorry, wait, what does that say after yield of this?
Variety, sorry, of this
You.
variety of wheat. So I'm going to just show you. It's all in the typed notes. I just hand wrote it. I just happened to handwrite it. So if you go back to the typed notes, I'm just going to show you real quick, and you go to page 15. So it's always the following page. Actually, it falls onto page 16 because I ran out of room on 15. You can see the problem here, and it's the completed example, and you can see the write-up right here. Exactly what I just wrote, but typed up nice, and you can actually read it. Okay, so we want to make sure we put it into words. All right, so that was the one thing that we could do with the normal curve and the standard normal curve, right? Find a probability. The other thing we could do is we can find a data value. So I want to show you that as well. So we're going to find the data value. And this is when we are given a probability. We want to find the corresponding data value. This is my inverse function, right? So if you're given the probability, it's like you're working backwards and you want to know the data value that corresponds to that data value. So let's work through one of these and we'll take a look at an example. So I want to look at example, I don't know what, I have 1A written down. I'm not sure if that's true. Page 18. We will move over and take a look. So, sorry, my phone just dinged. I never turned my volume down. There we go. Sorry about that, guys. So let's take a look at our day 2 notes. Let's take a look at page 18 and see if I'm, oh, it is. There we are, 1A. So on page 18, problem 1A. So here we're still studying that same problem that we just did, where we're talking about the white wheat that's grown locally and has a mean of 50, standard deviation of 5. 1A says use Minitab to determine the yield of this type of wheat for 1 acre field such that 97% of all 1 acre fields yield less than this amount. Okay. So I'm just going to write down the data we have. The mean is 50 and the standard deviation is 5. And what we're talking about is the 97th percentile. So let's take a look here. You know, we're going to draw it out. It's so nice to have this picture. So it says less than that data value. So I'm just going to quickly sketch my normal curve. And it says less than this value give 97%. So what it's saying is all of this area over here is 97% or 0.97, right? And so we want to know, what is this data value right here, right? So that's what we want to know. So this is really, we're studying the 97th percentile. 97% is below, 3% is above. So we're studying what is the probability that X is less than a certain data value gives me the answer of 0.97. That's what we want. We want to know that value. So we're going to use the inverse function. So I'm going to show you on Minitab here what we're going to look at. And so over here in Minitab, we're going to go back to the same place that we did before, calc, probability distributions, and normal. I'm gonna click on here. So it's gonna be the same thing that we just looked at for the last couple examples, but instead of cumulative probability, because that gives me the probability, I have the probability. I want the inverse cumulative probability. So this last option right here on the very top, and that's going to give me the data value. So I still need to give Minitab the mean and the standard deviation, which we have, right? 50 and 5. And instead of the whole column, like we just did in the last example, I'm not going to do that. I'm just going to put in a constant, so just a single value, which is that 97%. But you have to think mathematically here, and we don't talk about it as 97%, right? It's going to be 0.97. Okay, so think about how you have to change it into decimal form to really do anything mathematical wise, right? So 0.97. And I'm going to click OK. Then I get my answer right here. So you can see right here, I'm just going to confirm that I typed in 50 and 5. And then it says the probability X is less than X is 0.97. So I'm saying, okay, I gave it that the probability is 97%. The X value is 59.4040. So if I come back over here, what we're looking at is 59.4040 is that data value. Try to squeeze it in here. Leave myself enough room. 59.4040. Okay. And of course, we could put this into words as well. And you can write it a couple different ways. So what I do a lot of times with these is I refer to it as the percentile, like I just said. So like this is the 97th percentile because 97 is below. Okay. If the question asked about the other way around, like 97 above, that would mean that you would have 3% down here in this little tail, right? 97 would be above. So then that would be the third percentile. But here it said below, so it's the 97th percentile. So I would say like the 97th percentile is 59.4. 97% of all such 1 acre fields will yield less than 59.4040 bushels. Okay. I want to show you guys something before, because that was all I had, which is good timing because we can work on our daily. I just want to show you guys something on Minitab real quick with the decimals actually. So it automatically gave me 4 decimals here. And if maybe you want something different, maybe for your homework, you want 6, maybe ask for more, or whatever it is. I got to think of how, if it's going to let me do that. Oh, it is. So I'm going to right click. Okay, so I just clicked on it to highlight it. And I right clicked over the number 59. And the third from the bottom says decimal places. And look, I could do as many as I want. I could do 16. There it is. Okay. So what's really nice about that is if you need something for a calculation, you need more decimal places, you can get it. You don't have to just use what Minitab gives you, or maybe for your homework where you get some of those specific questions and it wants more decimal places. There you go. Okay. We can look over here at the typed notes if we want to see the write-up on that one. It should be on the next page, or right here it is actually. So right here, exactly what I said verbally, that the 97th percentile is 59.4, and then just put it into context here, the meaning of that number.